Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. In this tutorial, we will explore how to evaluate polynomials using the NumPy library in Python. NumPy provides a convenient way to work with polynomials through its numpy.polyval class, which allows for easy manipulation and evaluation of polynomial expressions. What is a polynomial? A polynomial is a mathematical expression consisting of variables, often denoted as x, raised to whole number powers, along with coefficients. A polynomial can be represented in the form \p x equals a underscore nx caret n plus a underscore n1 x caret n1 plus a underscore 1x plus a underscore 0 backslash, where a underscore n, a underscore n1, a underscore 1, a underscore 0 backslash, are the coefficients. N is a non-negative integer representing the degree of the polynomial. #NumPy's polynomial functions. NumPy provides several functions to work with polynomials, but the most straightforward way to evaluate polynomials is using numpy.polyval. Creating and evaluating a polynomial. Step 1, import NumPy. First, ensure you have NumPy installed. If you haven't installed it yet, you can do so via pip. Then, import NumPy in your Python script or interactive session. Step 2, create a polynomial. You can create a polynomial using the numpy.polyval class. The coefficients of the polynomial should be provided in descending order of powers. For example, let's create the polynomial \p x equals 2x caret 3 plus 3x caret 2, 4x plus 5 backslash. Step 3, evaluate the polynomial. To evaluate the polynomial at specific values of x, simply call the polynomial object with the desired x values. For example, to evaluate the polynomial at x equals 1, 2, and 3. Complete code example. Here's the complete code that incorporates all the steps mentioned. Output. When you run the complete code, you will get an output similar to additional operations. Derivatives. You can also compute the derivative of the polynomial using the .deriv method. Integration. You can compute the integral using the .integ method. Conclusion. NumPy's polyval class provides a powerful and easy-to-use interface for evaluating, differentiating, and integrating polynomials. This makes it a valuable tool for anyone working with polynomial expressions in Python. You can experiment with different coefficients and x values to see how the polynomial behaves.